Hi, Year 7. Now, following on from the PowerPoint, I said I was going to show you an experiment on how to do reflection. The first thing you need to do is to draw a straight line, and remember the symbol for to show the mirror with the dashed or the slanted lines at the back of the line. The next thing we do is we put our mirror on the line. Okay, now if you look, I've got a laser light here. The laser light, when it's pointing directly at the mirror, you can see that the light is going towards the mirror, so that's the incident ray, and is also being reflected straight back at the laser light. This is our normal line. The normal line is the line at which the light is reflected and comes straight back, and it's usually at 90 degrees. It's always at 90 degrees actually. So one thing you can do is to put a dot on the light. So that would be our normal line. We're going to connect that dot to our mirror in a minute. Then, in order to look at the angles of incidence and angles of reflection, remember the angle of incidence. Oh, sorry, I need to actually. Let me do that connection now so that I don't actually get mixed up. So it's going to be a dashed line for our normal line. Okay. So I put my mirror back on the paper. So it's good to use a plain sheet of paper for this. So if I move the laser light so that it is at an angle but still pointing towards the normal line, we can now see where our reflected light is and our incident ray. So I'm going to put a dot here as well, so I'm going to connect it. This is going to be our incident ray, and I'm going to put a dot here, and that's going to be our reflected ray, and then we can measure the angles. So let's do that now. So from that point there. Now, whenever you're drawing ray diagrams, you always have to make sure that the lines connect. If they don't, then you lose marks. Okay. So the arrows indicate which way the light rays are traveling. Then we can measure what the angles are, and the angles should be the same. So that's at 90 degrees. So from there to there, and there to there.
So Miss, am I measuring from the normal to the ray? Is that the angle that I want to measure?
Yes, from the normal to the ray, not over there, sorry. I put my thing on the wrong way around. Let me just turn this. Then it's easier for me to see. So if I put it on here, the angle is at 20. Oh gosh, I can't really read that very well.
Let's have a look. So it starts at 90 at the normal, yeah?
Yeah.
And it goes
10,
to
20. It's like 22.
112. So yeah, 22 difference between 90 and 112, right? Nice.
Yeah. So that would be like 22 degrees. And then the other side should be the same.
So
well.
should the other side also be 22
It
degrees?
should be also be
Okay.
22 degrees. So yeah, if we look over there, it's just about 22 degrees. It depends on how the line is drawn.
So the neater the line,
The neater the line.
the better the result.
So, and this is incident ray. Incident ray. Oh, that's for the line. And then that's the angle. And then this is reflected ray. And then this one will be angle of reflection.
And I'm willing to bet I can guess what the other angle's going to be called.
You're right, miss.
Is it the angle of incidence?
Angle of incidence. Okay. Now, one thing you guys can do, or if you were in school, this is what you would have done, is to now vary the angles, and then you are measuring different angles. So one can do it again, and then no, that has to be on the normal line. It has to be pointing towards the normal line. And then you can take, you can do more readings. Now, because you guys are not in school, obviously you can't do that. Here is a line I drew earlier. Oh, where is it? Here's a line I drew earlier. So if you're not going to have a ray box available to you at home, but one thing you can do is use your mobile phone.
Do you mean not everyone's cool enough to have a ray box at home, miss?
Imagine, miss. You're not. Okay, so you can use a mobile phone. You can make a slit in cardboard or very stiff card. And as you can see, you've got, if you move your camera back or your phone back, you can make the line a little bit sharper. I'm trying to get this thing straight. Okay, now you might need somebody else to help you here, because you will need to make a note of your normal line so that you're going to be connecting them together. And then you can use a mirror like this one. And if you put the mirror on the line, you can see that, oh, hold on. Is it going to stay?
On the hammers?
Oh, no, that's fine. Because if they're by themselves, they will have to be able to do this. Okay. So I've got the slit pointing, the light pointing towards the normal line. So again, make a note of where the reflected ray is. And then if you hold your mirror,
I just can't see the ray.
Oh, you can. Oh, sorry, miss.
Should I hold that?
Okay, yeah, you hold it, please.
Yeah, you need a couple pairs of hands with this one, guys.
Yeah. So I'm trying to. Okay.
So as you've seen here, if you're not getting a ray coming out, you may just need to angle your mirror so that the light is being reflected back onto the paper. Mm-hmm. So I'm pushing it forward a little bit. Okay.
And then we've got 3 points there. I'm just going to connect them together. Mm-hmm. Thank you, miss.
That's okay.
So we've got our normal line. Again, a dotted line. And then we've got our incident ray. And our reflected ray. Again, always make sure you add the arrows, and then you can measure using a protractor your angle of incidence and your angle of reflection, and they should be the same. If you don't have a protractor at home, you can always download one online that you can either print and use it to measure your angles.
Perfect. So all you need is a phone with a torch. You need some cardboard with a slit in it, a mirror, a ruler, and a protractor. And as Miss says, you can get one.
Pencil.
And a sharp pencil. And you can get one. You can get a protractor online if you need one. Thanks so much, Miss.
Thank you.